All right, so good evening once again, students. Now, yesterday we were looking at, the last thing we looked at was sketching a quadratic curve. And so we are going to pick up from there and continue onwards, all right? So just to go back through some of the things that we have done on curve sketching. So we say that in order to sketch a graph of a quadratic curve, we need the following. One, we need a turning point at the axis of symmetry. And we had discussed the axis of symmetry in the previous slide. So once we know the X and Y value for the turning point, now that point tells us that's where the curve is turning. So we can actually sketch a curve turning based on the turning point. So that's another reason for it, is to help us to know which direction we are going to sketch a curve. And if the curve is, if you look at the number in front of the x squared in the quadratic form, so in other words, in the form ax squared plus bx plus c, when a is a negative value, you will find that your curve is going to look like a mountain. And when x is a positive value, your curve will look like a valley. So you will know exactly how the curve will shape just by looking at the sign of the number in front of the x squared. All right, so that is the coefficient of x squared. Now, when the curve looks like a mountain, then the y value at the top of that mountain is called y max, or the maximum value for y. When the curve looks like a valley, then the y value at the bottom of the curve, we refer to it as the minimum value for y, so we call it y min. Or in short, we can say minimum and maximum value. So at that point, we know that the curve is turning. So hence, we need to first find the turning point. So that's one of the points that we need to find. The next set of points that we need to find is the point where the curve cuts the x-axis. And also, we need to find the endpoints. Now, where the curve cuts the axis, we're not just referring to the x-axis, but also the y-axis as well. Is that clear, guys? All right, so moving on from here now. We are going to look at this question that we had done yesterday, but we are going to go back to it. So we want to sketch this curve, not plot. When we refer to plot, plot is when we have the table and we take in all the points that we calculate from a table. That's the time when we say that we are plotting the graph. But when we are sketching the graph, we're going to use fewer points. So the curve itself not going to be as accurate as when we plot it. So that's why we say sketch. So when you make a sketch of something, it is not as accurate as how you would like it to be. All right, so these are the three main things, three main set of points that you need. So you need the turning point, the points where the curve cuts the x and the y axis, and you need the endpoints. All right. Now, to calculate the axis of symmetry, we use the equation x is equal to minus b. X is equal to minus b over 2a. Anybody remember what this equation is supposed to calculate? Anybody?
The y min, sir?
Not the minimum. No, this doesn't have to do with the min. This calculate the x value of the line of symmetry. So the x value through which that vertical line pass, which we call the symmetry or the axis of symmetry, this calculate that x value. So once you want the x value, you will use this formula to calculate the x value. Now the b and the a, you're going to take those values from the equation. All right, so if we go back to the equation that we are sketching, we will see that the b would be the number in front, the middle term, which is the x, the number in front, the x in the middle, that would be the b, and the number in front, the x square, would be the a. Now, where there's no visible number, a would be 1, all right? And so c would be just the last number. And when you are referring to these values, pay attention to their signs. You cannot refer to these values without taking into consideration their signs. All right, so if we are going to calculate the x value at the axis of symmetry, then we'll use b to be equal to -4 and a to be equal to +1. Is that clear, guys? So moving back to the calculation. So we're using the equation x equal to -b over 2a. We already know that b is -4, but if you're minusing a negative, so you would have to put that -4 in brackets. So we are minusing -4. Now, in the denominator where we have a, we know that from the equation a is 1. So we're going to put a in this, in the denominator and times it. We're going to put the value of 1 and times it by 2. And once we get that value for the denominator, so 2 ones 2 in the denominator, in the numerator, you multiply negative times negative, so you get a +4, and then you divide it by the 2 in the denominator, you will get the x value at the axis of symmetry to be equal to 2. All right. Now, this value for the axis of symmetry, which is 2, you can now plug this value into the y equation to calculate the y max or y min. Now, in this case, we would have a y min because the value in front of the x squared is a positive. All right, guys, hope you guys are following. So here now, for y min, we're going to now put in the value of x at the symmetry equal to 2. We're going to put this value now wherever x is in the equation. So we have x squared here. So we're going to put a 2 here. So we're going to get 2 squared. Where we have the x in the middle, we're going to put a 2 there. So we're going to have -4 times 2. And then, so we're going to do all that calculation in order to calculate the y value or the y min. All right. So if we do that, substituting the 2 in where the x is in the equation, we'll have 2 squared minus 4 times 2 plus 3. Now, after we do that calculation, we get y min to be 1. Now, the value of the x of symmetry and the value of the y min will give you a point, which we call a turning point. So to write this in the coordinate form, you would write the 2 first, which is the x value first, and then the -1. So the turning point would be x equal to 2 and y equal to -1. All right, now that point we need to find on our graph when we're going to sketch our curve. All right. So the turning point is 2, -1. Now, the next set of points that we need to find, we want to find when the curve cuts the x-axis. So when the curve cuts the x-axis, the y value is equal to 0. Now, if we put y equal to 0 in this equation here, so wherever the y is in the original y equation, we replace it with 0. So we get 0 equal to x squared minus 4x plus 3. And what we're going to do now, we're going to solve this equation by factorizing. All right. Now to factorize, you would have already known how to factorize quadratic. So in this case, we would find 2 factors of 3. When we add them, we get -4. It's a +3, so the 2 factors can be 2 positive or 2 negatives. So in this case, it will be 2 negative because the middle term is negative. So the factors, we factorize and then we solve for those values of the factors. So when we factorize this, we get x minus 3 times x minus 1. So these are the factors. Now, how do we solve for x? Now, we solve for x by taking each of these expression in brackets and equate it to 0 and then solve for x. So for the first bracket here, you would take the expression x minus 3, equate it to 0, and then now we solve for x. Bring over the 3, we get x is equal to 0 minus 3, which is just -3. All right, sorry, not -3, rather +3. Because when it was on the left side to be negative, so when we bring it over, it becomes +3. All right, guys. And in a similar way, we would solve for x minus 1 equals 0 to as well. So x minus 1 equals 0. And then we solve for x, so we bring over the -1, and then we would get x equal to +1. So what happened here, based on the 2 factors, we have 2 values for x. So if we have 2 values for x, it means that we also going to have 2 values for y. Now, how do we get the y values? Now, these x values, we substitute them back in the y equation where the x is, and then do the calculation. So when x is equal to 3, we put 3 squared minus 4 times 3 plus 3. And then we calculate that and we get that y value for this x equal 3. And then we do the same thing with x equal 1 now. So we put 1 squared minus 4 times 1 plus 3, and then we'll calculate the y value for x equal 1. Now, after we get the y values, then we write the points for those x value, those values. And these would be the values at which the curve cuts the x-axis. All right, so when we solve x equal to 3 or x equal to 1, now we know that it would cut the x-axis at, remember, we already know what y should be at x equal 3 and x equal 1, because remember, y would be what? Y would be equal to 0. So it means that the coordinates for these would be x equals 3 with 0. So that's 1 point. And the other point going to be x equal to 1 and y equal to 0. So these are the 2 points, and these are on the x-axis. So you look on the x-axis, just look for x equal 3 and look for x equal 1, and you know that the curve going to cut the x-axis at these points, these x values. All right, so it means that we would have calculated the turning points. We'd have calculated these 2 points where the curve cuts the x-axis. So what we need next is to find where it cuts the y-axis. Now the curve cuts the y-axis when x is equal to 0. Now, don't get them confused. The curve cuts the x-axis when y equal to 0, and the curve cuts the y-axis when x equal to 0. So all you're doing, you're just flipping them around. So when you're calculating where it cuts the x-axis, you make y 0. When you're calculating where it cuts the y-axis, you make x 0. All right, and so that's the idea here. All right, so these are the 2 points where it cuts the x-axis. Now we need to find where it cuts the y-axis. And the curve cuts the y-axis when x is equal to 0. So in the equation up here, the y equation, we're going to put x equal to 0 in this equation. So here we would put 0 here. So we will get 0 squared. We put 0 here, we get minus 4 times 0. And then now we do the calculation. So when you calculate 0 squared, you get 0. 4 times 0, you get 0. So y is going to be equal to 3. So that calculation is not so bad. Now, if y is equal to 3 and x equal to 0, then the point would be x equals 0 and y equal to 3. So that would be the point at which the curve cuts the y-axis, right? Where it cuts the y-axis. So this is where it cuts the y-axis. And up here is where it cuts the x-axis. Don't confuse them, right? So these cut the x-axis and this cut the y-axis. And generally for quadratic, the curve usually cuts the x-axis at 2 places on the x-axis, all right? Now, it generally cuts the y-axis only at 1 point. So when it cuts the x-axis, it cuts it usually at 2 points. But for the for the y-axis, generally 1 point. In some cases, it may not cut the y-axis at all. And in some cases, it might not touch the x-axis at all. All right. All right, so with that said, let us move on. All right, so here we are. So we say that when x is equal to 0, y is equal to 0 squared minus 4 times 0 plus 3. So we get y equal to 3. So the curve cuts the y-axis at 0, 3. All right, now what other points we need? So we said that we need 3 sets of points. We need the turning points, the points where it cuts the y and the x-axis. So we had calculated those just now. And the points that we need next is the endpoints. Now the endpoints, you take the x values based on the range. Going back to the question now. If you go back to the question, you will realize that the range of x values start from -2 up to +6. So it means that the endpoints, the x value would be -2 and +6. These are the x values at the endpoint. How would you find the y value now at these endpoints? Well, these are the x values. You just plug these in the equation here for x and calculate the y value for each of them, all right? So when x is equal to -2, you put -2 square in this, and then you have 4 times -2 plus 3. Now, after you finish calculating for -2, you do the same and calculate for +6, and then you'll get the 2 y values for these two here So when x equal to -2, you will get a y value for that. When x is equal to +6, you get another y value for that. And those will give you the points for the endpoints. All right, guys. Any question? Moving along.
Yes, sir. So that means there are only two things supposed to be put on it then, on the graph.
Only?
Only 2 points.
So so we have a set of points that we are using to sketch a curve. We're using the turning point, we're using where it cuts the axis, and the 2 endpoints. So we're not going to take all the values that we usually use when we are using the table, right? So when we sketch a graph this way, it is really should shorten the process of using the table, right? So in other words, you're not plotting all the points, so it should take you less time to sketch it than when it takes to plot. All right, because when you're plotting, you have to use all the x values based on the table with the y values that you calculate. So you'd have to calculate all the values in the table first, then you use those values from the table to plot the graph. But when you're sketching, you just need the turning points. You need the points where it cuts the x and y axis and the 2 endpoints. And then now you can connect those points and get a fairly good picture of what the curve will look like. It won't be as accurate as when you plot it because you're using more points in the plotting, so it will be more accurate. Whenever you use less points in your graph, the graph is less accurate than when you use more. All right, guys? So here we are now at the endpoints. So we want to now find out at the endpoints what the value for y is, or the values for y, what are they? So we put in the 2 x values and calculate. So when x equal to y equal to -2 squared minus 4 times -2 plus 3, and we calculate y to be 15 when x is -2. So we are going to write those as 1 point. Then we calculate the other point when x is equal to 6. We plug in the value 6 squared minus 4 times 6 plus 3, and we get y to be 15 too as well. So for that point, the end point is going to be 6 and 15. All right, so we would have had now all the points that we need to sketch the graph. And so all we need to do now is to just sketch. Now, when we're sketching, we don't even have what you would call, we don't even need to use a scale. We can just use a rough estimate where these values would be on the graph. Now, if we are going to use these points to sketch our curve, so these are the points that you would need. Now, for the curve, it would look something like this when we put in the turning points where it cuts the x-axis, where it cuts the y-axis, and the endpoints. All right. So we know that it would have cut this value here should be up here. So x equals 0. So this should be right here. All right. For some reason, it's not in the right place. I guess I need to fix this slide. All right. And where it cuts the x-axis now, it cuts the x-axis here. So this is 1 point here. And this is where it cuts it at x equals 3. So it cuts it here. So all we need to do is mark this point here, mark this other point here. Now we have x equal 2 with -1. So it would come to right here. So this is where the turning point would be. And then now up here is where you have the endpoints. So 15 would be somewhere around here. 15 be somewhere around here. So x equal -2 and 15 would give you this endpoint. X equal to +6 and 15 give you this endpoint. So you see, we don't need all the graph, all the points that we would normally use from a table to sketch this graph. You only need all of these. Because once you have the endpoints, you have the turning points and where it cuts the curve, you can just do a freehand and connect those points together. And then you'll get a fairly good sketch of the graph. Now, so as I said before, the sketch won't be as accurate as when you plot it, because in these areas, you would have missed out these points. So when you're freehanding to draw this, you wouldn't have any points in between here that you're connecting. So you'll just have to use your eyesight to kind of line up with the point where it cuts the curve and so on. So that for that reason, you won't get an accurate graph. Is that clear, guys? Is everybody following what I'm saying? Any question? Now, for your purpose, I don't see you are getting anything like this on CSEC paper, but you're required to know it, because if you decide to continue with math, you will learn some of these techniques when you go to a more advanced level in maths. So you are just getting these as foundation, so that if you're going on to higher level maths, you will know these basic things. All right. All right. So with that said, you should practice this, but I wouldn't hurt my head for exam with this. All right, guys. Now you should know though how to find the turning point, because sometimes they can ask you what is the turning point, or what's the x value, what's the y value. They can ask you those questions. All right. Now the next thing that we're going to be looking at is solutions of equation by graph. Now, we may solve equations without graph. We generally do that by making the unknown the subject. Now, unfortunately for us, we have not done any equation yet in algebra, but we are about probably one topic away from equation. So after we are finished with algebraic fractions, then our next topic will be equations, and that will cover all the topics that we need to do in algebra for the makeup class. Yes, Miss Brown.
Sir, unrelated to this, sir, do you know the date?
Could you speak a little louder, Miss Brown? I'm not hearing you at all.
Can you hear me now?
Yeah, if you talk a little louder, still it would be better.
I'm saying that unrelated to this, but do you know the date for the math CSEC?
Oh, you mean the exam date?
Yes, sir.
I don't have any idea what the date is, but what
It's 11th.
It is a
11th of next month.
or 11th of May. Well, it is pretty moving pretty quickly. All right, so it means that we really don't have much time to, we'll have to, we'll have to see if we can look at some questions before then. So maybe, so it's not so far away. All right, let's see what will happen by next class. Probably the next week we can see what we can look at. All right, guys. Usually I don't know why the date is being rushed so closely now, Usually it would have been done a little later, like about maybe the 18th or so, but I guess they're trying to speed up everything. All right, so solution to equation by graph. So what we have here now is we're looking at how we can plot these equations on a graph to solve for the x values. And it's pretty much plotting the graph, just like we did the one before with the table. So you're going to construct a table from the equation, and then now from that you can now calculate your y values. Then you plot your graph, and the solution is pretty easy and straightforward. Now, we're going to try and go through this graph quickly and plot it. So here we have our axis here. Now, if we should draw our x-axis, now, well, we generally start with our y-axis first. So we want to draw the y-axis so that we can go 3 places to the right of the y-axis and 2 places to the left. So we can pretty much put it anywhere almost close to the center here. So if you want, we can put our y-axis here. All right, so the next step, what we need to do now is to decide now where we're going to put our x-axis. So here we would have